So when you run a program, so it is divided into very smaller tasks. So one task will complete. Some tasks are parallel tasks. Some tasks are interdependent tasks. So after completing the task by the task one, so it gives data to the task two. There are some tasks which is dependent on some other tasks. There are some other tasks which are parallel tasks. They will run parallelly. So there should be some communication between these tasks for exchanging of data and resources, not resources, data. So synchronization is very essential for this task to share the maximum resources between them to parallelly done the task. For example, task A need a result from task B. So task A can run only after task B produce the result and give the data to the task. Until then, it will wait. So it is a dependent task. So you need a synchronization between all these tasks. So this synchronization is achieved by two types of mechanisms. One it is event objects, another one is semaphores. So what is event object? So event object is used when the task does not require any resource sharing. So resource sharing is not required means then we go for this particular event object. So this allows one or more tasks to wait until a specified event occurs. So there are two stages in this event object. One it is triggered and another one is not triggered. So in event object, in a triggered object state indicates that the waiting task may resume. So here there are three figures given. There are two non-triggered events and one triggered events. So here this is task A and this is task B. So task A is creating some resources. It is using this lamp. Okay, task A is using this lamp. Now task B is doing some other work. So it is in the non-triggered state. So it will do some other task other than utilizing these resources. This is non-triggered state. If it is a triggered state, so after finishing this task A, so the task B will continuously read the status of task A. When it is free, it will capture these resources. So this is triggered state. So in the non-triggered state, both are doing some operation when necessary. Capture the resource. So here there is no resource sharing. So entire resource is separate. Only one task is capturing the resource at a time. So resource sharing means at the same time both the tasks sharing the resource is called resource sharing. Here only one task is sharing the particular resource. So here there is no resource sharing. So one task is utilizing the resource for a particular time. After some time, another task is utilizing the same resource at the other time. There are two states, triggered state and non-triggered state. So if it is a triggered state, the task B is continuously checking the task A, whether it is utilizing the resource or not. So if it free the resource, task B is capture the resource. In non-triggered state, so it will not worry about the other task what is doing. So it will do its process. When it is required, so it will take the resource. So for example, here there is a problem occur. For instance, task A is reading a set of data which is updated by task B. Task A may receive corrupted data. For example, resource sharing means there are two tasks. they are utilizing a resource, for example, memory. The task A is reading the data from the memory. At the same time, task B is changing the data in the memory means. So task A will get some erroneous data. So to avoid this problem in event objects, so they go to for another method called semaphores. So semaphore is a advanced technique when compared to the event objects. So event objects is nowadays not utilized in any of the systems. So what is semaphore? So semaphore is controlled by operating system. It is primitive for controlling access to critical regions. So this is very essential. For example, critical regions means we say it is very essential. For example, we say money for human. So money is a very critical thing for a human. So we have to use the money, utilize the money very effectively. So likewise, for this particular system, some areas are called critical regions. We are calling that the resources are very expensive. So we have to use that resource very carefully. So in order to access these regions, we are using semaphores. So what is semaphore? So semaphore is an object created by the operating system kernel, so that one or more tasks of execution can use this region. So at the same time, more than one task can utilize this particular critical region. So this while accessing this critical region, so you have to maintain some how to release the source, how to acquire the source, how to have a synchronization between tasks. This is maintained by these semaphores. The semaphores is controlled by the operating system. So what is a semaphore? So semaphore is like a key that allows the task to carry out some operation or access a resource. So semaphore is like a key. That key is given to a particular task to do some operation. So for a particular semaphore, there are a lot of keys. There are several keys for a single semaphore. If a task occurs a semaphore, it will carry out the operation or access the resource. Otherwise, the task is blocked, and if it chooses to wait for the release of the semaphore. For example, a semaphore is a waiting room. For example, it is a room in a hotel means. If it is a single room, we will say if it is a single room means it gets a single key. Like this, semaphore has a key. Okay. So if a particular person wants the key means he has to access the permission, and if he gets the key, he can go inside and do the operation, and he can wait and he can use that and come again. So it is for a single room. So if here for a single room, if it is a very big room, a big area, and there are a number of rooms means so a large number of keys. So like this semaphore is a big area. So in this big area, so for a particular semaphore, it has large number of keys. It has several keys. Okay. So if you want a particular task, want to do a particular operation in one of the area of the semaphore, so it should acquire the particular key and it should do the operation and or access the resource. So if the permission is not given, he has to wait until so if some other person, some other task is utilizing that resource means he has to wait until the key is released by the semaphore. So the semaphore manages all the task synchronization by using several keys. Okay. So if the key is already used by some other task, this particular task has to be wait. The key is free means you can use that key to do this operation. So semaphore has an associated resource count and a wait queue. So for example, I am telling it is a very big hall lot of rooms are available. So we assume that the rooms are resource. So 10 rooms means we say that it has a 10 resource count. So wait queue means already 10 people are there. So the 30 people are coming. So these 30 people are in the wait queue. So resource count indicates the availability of the resource. Wait queue manages the task waiting for resources from the semaphore. The semaphore functions are like the key, whether they define whether the task has access to the resource. So every room has a key. So whether the task is given to the particular, whether the key is given to the particular task or not. So these are managed by the semaphore. When the task gets access to the resource, when it occurs a semaphore. So when the key is received by the task, so it will go to access the resource. The resource count of the semaphore determines the number of times the semaphore can be acquired. So if the resource count is 10 means, so the semaphore can be used 10 times. So when a task occurs the semaphore, for example, I have 10 rooms. First room, I have 5 people are already allocated. So my count moves from 10 to 5. So when a task occurs a semaphore, so it count decrement by 1. So whenever a room is allocated, it will decrement by 1. So likewise, when a person complete its operation, he will move out means that count will once again increment by 1 when the task releases the semaphore. Okay. So this is managed by using a key. So task is given a key and use the resource. After finishing the resource, so it will release the key once again to the semaphore. There are 3 types of semaphore: binary semaphores, counting semaphores, and mutually exclusive semaphores. So semaphore value is either 0 or 1 to indicate availability or unavailability. So here there is a single room. So you have to wait whether it is available or not, 0 or 1. So counting semaphore means, for example, if it is a parking lot. So even though it is a parking lot, it has a limited resource. It can, for example, a car parking means you can park up to 50 cars. So semaphore has a value. So it is resource count is 50. You cannot park more than 50. So the semaphore value, either if it is 0 means you cannot park after this, or greater than 0 means you can park as many numbers as indicated by the counting semaphores. So when a particular car occupies a space, its count is decreased. When a car is released from the parking lot, now the car now it is increased by 1. So this type of semaphores we are calling as counting semaphore, and mutually exclusion semaphores. Here also it will indicate whether the semaphore value is available or not, 0 or 1. But there's also a log count. Log count means so while a particular task accessing the resource, he will log the resource. After completing its operation only, it will release the resource. You cannot do a time slicing or mutually sharing in this particular mutually exclusion semaphore. I will come to this later. Okay. First, binary semaphore. For binary semaphore, there is a critical section means a single. Let us take a single car parking lot. So a single car can park. It can enter. It can exit. Okay. So in this case of OS, if some task to run a critical section, the task occurs a corresponding semaphore. So one car is coming, the car parking lot is free, so it will go and park in the lot. It also signals to other tasks this matter. So in this particular type of semaphore, it will indicate that I have parked the car. This information is given to all other tasks, all other persons in the parking lot. Okay. So when the task exits the critical section, now the semaphore is released. So when the car moves from the parking lot, the area is vacant. Now semaphore is released. Now other waiting tasks try to use the critical section. So, for example, if you have a bike and you go to the crosscut street, uh, there are a lot of vehicles parked in there. If a lot of people, new people will come. So, புதுசா நீ போறேன்னா ஏகப்பட்ட பேர் ஏதோ ஒரு வண்டி எடுத்தோடனே போய் பார்க் பண்ண போகும். ஸோ ஏற்கனவே நிறைய வண்டி நின்றுட்டு இருக்கு, நம்மளுக்கு பார்க் பண்றதுக்கு இடமே இல்லை, யாராவது ஒரு ஆள் எடுக்க மாட்டானா அப்படின்னு வெயிட் பண்ணிட்டு இருக்கோம். ஸோ யாராவது ஒரு ஆள் எடுக்கும்போது அந்த இடத்துக்கு போய் பார்க் பண்றதுக்கு 2-3 பேர் நிற்போம். Like this, when a particular car is removing, particular critical section is removing, so other tasks will try to use the critical section. So in order to which task to use the critical section, it is decided by the semaphore. So semaphore will make a priority and it will allow which task has to use it. So this function is created by, this is handled by the semaphore. So when the car is, when the place resource is available, it will indicate that by a 1. If the resource is unavailable, means it will indicate by 0. So binary semaphore is third resource and any task may release it. So after utilizing it, it may release the task. The next one is counting semaphore. As I already told, it is a parking lot. It has a parking lot of 8 cars. So semaphore value is incremented or decremented. So when the car enters means it will be decremented. And when the car leaves means it will be incremented. So when a car enters the car park, semaphore is decremented by 1. When the car leaves the parking area, semaphore is incremented by 1. When the car is fully occupied, all 8 slots are available means now the semaphore value is 0. So 1 means available, 0 means unavailable. When the full parking lot is full means semaphore value is 0 and new car is not able to enter inside. So now the semaphore value becomes negative because some person is waiting. So all 8 cars is available, now a count is 0. When a new car is coming, so it goes to negative because negative indicates that a person is waiting outside. Okay, this is a diagram for this. So this is counting semaphore. This is similar to the case of operating system, a bounded buffer problem. So memory with limited size. You cannot use the memory above the limited size. So bounded buffer problem is a problem. Here the memory is divided into number of blocks and each block is accessed by a task. The number of tasks accessing the buffer is limited to the number of blocks. So number can be used as a count n, as a counting semaphore to assess the different blocks of the buffer. So instead of car parking is an example to understand. So what is happening in the system? So because it is an operating system. So here the resource is memory. The memory size is limited. So the memory is divided into number of blocks, and each block is accessed by a particular task. The number of tasks accessing this memory, so particular block is called buffer, is limited within the number of blocks. For example, my number of blocks is 50. So I can use tasks less than 50. Okay, you cannot go increase the task greater than 50. So the number of tasks accessing the buffer should be limited to the number of blocks. So it should be less than 50, not more than 50. So the number is counted as the n of the counting semaphore. So this number is the counting semaphore of the count of the sounding semaphore. Okay. When n equal to 0 means you cannot, so all the blocks are accessible, all the buffers are used, you cannot, no task is able to access. So counting semaphore gives us a count to more than one task. If 0 means unavailable, greater than 0 means it is available. Some device buffer is available for using for if any new task uses that unavailable buffer. So if there is a limitation means we are calling as a bounded. If there is no limitation means it is unbounded. So counting semaphore is also a shared resource, and it can be used by a particular person task release means another person can use it. So it is a shared resource. Finally, mutual exclusion semaphore we are calling as mutex. So it is a lock of a resource. So a particular task will lock the resource. So how it is working, we see. A task or thread takes this lock and uses it for itself. So while it is using, it will not allow anyone to use the resource. At a particular time, the task wants a lock. So after using the resource, the task releases the ownership of the task by setting the mutex to 0. So here it will take a lock and it will use the resource. So after using the resource, it may release the lock so that other can use. So after using the resource, if it is not release the lock, it cannot be used by other resources. Okay. This is the problem in mutual exclusion semaphore. So mutex is a special binary semaphore that supports the ownership and often recursive access, and only the task that lock the mutex can release it. The mutex is created in unlocked state, whose state diagram is shown in figure. So what is the difference between this mutual exclusion semaphore and binary semaphore means? In the binary semaphore, if a particular task uses the resource and if it finishes work means the kernel itself will release a semaphore to the another task. Here, whatever task utilizing that particular resource only release the resource. Then only other task can use that resource. This is the difference between the binary semaphore and the mutual exclusion semaphore. So what is the difference between binary semaphore and mutual semaphore is, they given an example. It is like a room. So binary semaphore is like a gatekeeper to a room which has only one bed for sleeping. So once the occupant leaves the room, the gatekeeper indicates signals to others the room is free. In the other context, in the OS context, tasks waiting to get access to resource don't have to keep checking for its free status. Semaphore signals to them the status. So in the binary semaphore, when a particular task completes its operation, so it will signal to all other tasks that the particular semaphore I am free. This particular resource is free. So other tasks need not to be wait. You can do some other operation. So this is a binary semaphore operation. In case of mutex, if a particular occupant gets a key of the room from the reception desk, use the room and returns the key to the reception when leaving. So some other people also use the same room, means they have to check the reception counter whether this first person has leave the room or not. So every day, every time they have to check whether the resource is free or not. They have to check at the reception counter. In the OS context, this is puts in a queue, waiting task in a test and wait loop leading to inefficiency. So there is a waiting queue, there is a delay, so efficiency is very much reduced. So this is the difference between binary semaphore and the mutex semaphore. So when you look at these three semaphores, counting semaphore is a bounded type. Binary semaphore is a single resource, and which mutex semaphore is needed when if you want some privileges and some security is needed, means you go for the mutex semaphore. So this diagram indicates that what? Anyone tell? There is a signaling, there is a train coming, there is a bridge. What indicates this diagram? The diagram la enna puriyudhu? இந்த பக்கம் ஒரு ட்ரெயின் இருக்கு, அந்த பக்கம் ஒரு ட்ரெயின் இருக்கு, சரியா? பிரிட்ஜ் தான் ரிசோர்ஸ். அட் எ டைம்ல ஒரு ட்ரெயின் தான் போக முடியும். இப்போ ஒரு ட்ரெயின் யூஸ் பண்ணிட்டு இருக்குன்னா எய்தாப்புல இன்னொரு ட்ரெயின் வருதுன்னா அதை ஸ்டாப் பண்ணணும். ஸோ இந்த ட்ரெயின் வந்து இந்த பிரிட்ஜை யூஸ் பண்ணுங்கிறத சிக்னல் பண்ணணும். Then only other train driver will indicate that that bridge is used by some other person. So they have to wait in a common area, two bridge area, so that this train should leave that particular area. So this is a type of semaphore ne யோசிச்சு next class சொல்லுங்க. So next topic is modeling tools. Modeling tools or modeling methods. This is common in any programming. So if you go for a digital system design, these modeling methods are available. So if anyone knows what is programming for digital electronics, have you designed any circuit? Do you know the modeling software for digital system design? So C, C++, Java, இதெல்லாம் வந்து language. So embedded system னு போனீங்கன்னா, so what is the device you are going to use? Whether I am using ARM controller, or whether I am using 8051 or I am using Arduino. So the programming software will differ. So depending upon the device you are going to use. So when you are using a device, so that programming related to that device, you have to utilize it. Okay. So before do the programming, so what we do? We will design the steps. So my operation, first you determine the operation. எனக்கு இந்த ஆபரேஷன் பண்ணணும், நான் வந்து 2 பிட் ஆட் பண்ணணும், எனக்கு ஒரு அவுட்புட் 2 பிட் ஆட் ஆகி கிடைக்கும். ஸோ ஆட் ஆகும்போது கேரி வரலாம். இது ஒரு சிம்பிள் ஆடர் சர்க்கியூட். ஓகே, நான் 2 பிட்டை ஆட் பண்ணோம், எனக்கு அவுட்புட்ல கேரி வரும், சம் வரும். இது வந்து என்னோட பிளாக் டயக்ராம். ஸோ இதை வந்து நீங்க என்ன பண்ணுவீங்க, ஒரு ஃப்ளோ சார்ட் எல்லாம் போடுவீங்க. ஸோ ஆஃப்டர் determining the operation, you write the steps. For first steps, algorithmic steps. Get the first number, get the second number, add the 2 numbers, produce the result. This is algorithm steps. Then what we do, we go to the flowchart. Flowchart la nodunga adeda, get the number, add 2 numbers. Algorithmic steps is written in words. Flowchart is used to give the steps in a diagrammatic way. So steps easier, flowchart easier nu ketta flowchart தான் ஈஸி. ஏன்னா ஈஸியாக பார்த்தா டக்குன்னு அப்சர்வ் பண்ணிடலாம். ஸோ ஸ்டெப்ஸில் வந்து if this particular if condition false, we go to step 9 அப்படின்னு எழுதுவோம். ஆனால் ஃப்ளோசார்ட்டில் ஒரு லைனை போட்டு அந்த இடத்துக்கு மூவ் பண்ணிடும். ஸோ ஃப்ளோசார்ட் படிக்கும்போது ஈஸியாக இருக்கும், ஸ்டெப்ஸ் படிக்கும்போது கொஞ்சம் கவனமாக படிக்கணும். ஸோ ஆஃப்டர் டூயிங் த ஃப்ளோசார்ட், what we do, we have to write the logic according to the language of the particular device. According to the language of the particular device. That is known as modeling. So modeling la 3 type of modeling irukku. So one it is sequential modeling. So sequential modeling indicates that na enna first செய்ய போறேன், செகண்ட் என்ன செய்ய போறேன், தேர்ட் என்ன செய்ய போறேன், ஃபோர்த் என்ன செய்ய போறேன். இப்படி சீக்வன்ஸா மை ஆப்ரேஷனை சொல்லி அதை மாடல் பண்ணனா அது வந்து சீக்வன்ஷியல் மாடல். அடுத்து வந்து டேட்டா ஃப்ளோ மாடலிங். டைம் ஆச்சா? ஓகே, ஃபினிஷ் திஸ் ஒன். டேட்டா ஃப்ளோ மாடலிங் மீன்ஸ் அதுக்கு உள்ள டேட்டா எப்படி மூவ் ஆகுது, எங்கேருந்து இன்புட் வருது, எப்படி டேட்டா போகுது. நான் ஸ்டெப்ஸ் எல்லாம் சொல்லலை, என்ன ஆப்ரேஷன் சொல்லலை, எந்த டேட்டா எங்கே ஆட் ஆகுது, எங்கே ரிசல்ட் போகுது. இதுதான் டேட்டா ஃப்ளோ மாடலிங். ஃபைனலி வந்து ஃபைனைட் ஸ்டேட் மிஷின் அப்படின்னு ஒன்று சொல்கிறோம். ஸோ இதில் வந்து என்னென்னா ஒவ்வொரு ஆப்ரேஷனுக்கும் ஒரு ஸ்டேட் கொடுத்துட்டு இந்த இன்புட் வந்துச்சுன்னா இந்த ஸ்டேட்டுக்கு போகும், ஸோ இந்த இன்புட் வந்துச்சுன்னா வேறு ஸ்டேட்டுக்கு போகும். ஸோ ஒவ்வொரு இன்புட்டுக்கும் என்னென்ன ஸ்டேட் வருமோ அதை எல்லா ஸ்டேட்டையும் முதல்ல கண்டுபிடிச்சி வச்சுட்டு அந்த ஸ்டேட்டு ஒவ்வொரு ஸ்டேட்டுக்கும் மூவ் ஆகிறத வந்து நம்ம ஃபைனைட் ஸ்டேட் மிஷின் மெத்தட்னு சொல்லுவோம். ஸோ இந்த 3 டைப் ஆஃப் மெத்தட்ஸ் we are using in digital system design. So the embedded system is not a new one, it is a digital system design is the base for the embedded system. Okay. So digital electronics படிச்சாதான் இது புரியும். Okay. So yes sir.
அவங்க டிஜிட்டல் எலக்ட்ரானிக்ஸ் எப்படி படிச்சாங்கன்னு அவங்களுக்கு நல்லாவே தெரியும். முற்பகல் செய்யும் பிற்பகல் தானே விளையும். ஓகே ஓகே சார், கண்டினியூ சார், கண்டினியூ.
டைம் ஆயிடுச்சு சார். So we will see how to model these methods in the next class. Next class இருக்குமான்னு தெரியல. ஸோ டிசம்பர் 12க்கு அப்புறம் தான் பார்க்கணும்.
சார் அவ்வளோதான் முடிஞ்சிருச்சு.
ஆமாம் சார்.
Kana, I hope everyone attended first hour. Am I correct? Hello? Kana, first hour எல்லாரும் அட்டெண்ட் பண்ணீங்களா?
எஸ் சார்.
அந்த பிளேஸ்மெண்ட் ரிகார்ட் மேம் சொன்னதெல்லாம் கொஞ்சம் நோட் பண்ணியிருக்கீங்களா? Any doubts regarding that? Hello? Representative? Hello?
சார் கேக்குது சார்.
மேம் சொன்னதெல்லாம் நோட் பண்ணிருக்கீங்களா?
சார் அக்ஷய் நோட் பண்ணுங்க சார், நான் அக்ஷய் சார் கால்.
சரி, ஓகே. உங்களோட அந்த இது அஜெண்டா படி எல்லாம் ஸ்டார்ட் ஆயிரும். பிளேஸ்மெண்ட் அண்ட் நான் பிளேஸ்மெண்ட் ஸ்டூடெண்ட் எவ்ரி ஒன் நீட் டு அட்டெண்ட் த ஆப்டிடியூட் கிளாஸ். ஓகேவா? We will get into you in the separate batches. We will put a separate meeting for everyone. Do attend the same. Okay, thank you. So thank you, sir.
Sir. சார் சார்
எஸ்
சார் அவங்க 2 பேட்ச் சொன்னாங்க சார். இந்த பேட்ச் எனக்கு ஜாயின் பண்ண முடியுமில்ல சார்?
அந்தந்த பேட்சுக்கு அங்கங்க மீட்டிங் வைப்பாங்கல்ல, அந்த மென்டார்ட்ட டீட்டெயிலாக பேசுங்க. ஓகேவா?
ஓகே சார், நீங்க சொல்லுங்க.
ஹலோ.
ஓகே சார், ஓகே சார்.
Okay, okay, thank you. Sir, thank you, sir. Sundar Ganesh, sir. Thank you very much.
Okay.
We will end the call, sir.
So we will see after December 12th. You study the aptitude properly. So ஏதாவது டவுட் இருந்தா படிக்கிற பசங்கிட்ட கேட்டு தெரிஞ்சுக்கோங்க. ஷார்ட்கட் என்னென்ன இருக்கோ, ஸோ எல்லா கொஸ்டினுக்கும் ஷார்ட்கட் இருக்கும். ஷார்ட்கட் தெரிலன்னா உங்க உங்க கிளாஸ்லேயே கேளுங்க. அவனுக்கும் தெரியலன்னா சீனியர் பசங்கிட்ட யார் வேணும்னு சொல்லுங்க. சரி, எனக்கு இந்த பர்டிகுலர் டாபிக்ல எனக்கு சம் போட தெரியல, ஷார்ட்கட் வேணும் அப்படின்னு சொன்னீங்கன்னா நாம சீனியர் பசங்க கான்டாக்ட் தரேன். அவங்ககிட்ட கேட்டு படிங்க. ஏன்னா ஆப்டிடியூடு போடுறதுக்கு வந்து டைமிங் தான் முக்கியம். ஸோ எல்லாரும் சால்வ் பண்ணிடுவோம். ஸோ எவ்வளோ சீக்கிரமா சால்வ் பண்றோம் அப்படிங்கிறது தான் முக்கியம். ஸோ நீங்க செஞ்சு பார்த்தா தான் உங்களுக்கு தெரியும் எந்த இதுல உங்களுக்கு ப்ராப்ளம் வருதுன்னு. ஸோ டூ இட் அண்ட் ஆஸ்க் யுவர் கிளாஸ்மேட்ஸ் and find the shortcuts. First find the shortcuts for all the topics. ஸோ இந்த ஒரு டாபிக் எடுத்தாலும் ஒரு 5 டைப் 6 டைப் தான் ப்ராப்ளம் இருக்கும். ஸோ அதுக்குள்ளேயே தான் சுற்றி வேற வேர்டிங்ஸை போட்டு கேட்டிருப்போம். ஸோ நீங்கள் கொஸ்டின் படித்தா புரிஞ்சிடும். அந்த 5-6 டைப்புள்ள எல்லா ஆப்டிடியூட் கொஸ்டினும் வந்துடும். ஸோ எல்லா டாப்பிக்கையும் செஞ்சு பாருங்க. செஞ்சு பார்த்தா தான் உங்களுக்கு வரும். சும்மா அப்படியே படிச்சு போனால் அங்கே எக்ஸாம்ல எழுத முடியாது. ஸோ எல்லாத்தையும் செஞ்சு பாருங்க. டவுட் இருந்தால் உங்கள் கிளாஸ்லேயே கேளுங்க. அப்படியே அவனுக்கும் தெரியலன்னா சீனியர் நம்பர் தரேன், அவங்கள்ட்ட கேட்டு படிச்சுக்கோ. If you have any doubts, we will see in the next class.